Good evening, everyone. My name is Omar Abdullah. I'm a data science student at a Spanish university called UCamp, and we have a sister college in Sharjah, so I don't have to speak Spanish for my, dissertations and stuff, you know. But yeah, I'm also a community builder as well, just like he is. I work for JA Worldwide as a community builder, but that's not what I'm here today. I'm here to talk about certain project that I've been wanting to do for like a few weeks now, and that is traffic congestion predictor. How many of you guys really, really despise traffic right now in the UAE? Okay. It's pretty much everybody. How many of you have came all the way from, let's say, Dubai, Abu Dhabi? I mean, in Sharjah or any other? Okay, everyone. Yeah, it's a pain, right? Like every single day, you just, especially as I am, I had to literally leave at like 4 a.m. in the morning to go to my job. Sometimes it's tough, right? So I created a solution basically, which is a traffic congestion predictor. And what makes this different is that is a multimodal data. Basically, we're fetching like three types of APIs. So we're taking from open weather, so we're taking the case from basically the traffic and as well as the weather, so that we can also simulate the what ifs. And also this project is great because you can also do it on a low IoT infrastructure. So anyone has like an IoT infrastructure anywhere, or maybe on low edge devices like Raspberry Pi or something, this project is perfectly fine. And it is great to run those projects as well, because it just makes it easier for us to run the traffic predictor as well in real time. Because the issue with running those projects is that a lot of times they use either historical data or they use the synthetic data, which I mean, it's fine when you're experimenting stuff. But the main issue is that you want it in real time. So for example, last year, and I don't know if you've been here, but we basically had like a year's worth of rain in like a single day. So like even the based on historical data, that's never happened before. So you want to get those predictions as well. And I'm just going to show you the code right now. And yeah, yeah. I'm just you guys can see the code, right? Oh, okay. Okay, let me just. I don't know. You zoom it on freaking control plus. Okay. Okay. Just. Okay. Okay, that's enough. Okay. So let me just give you the overview of the system itself. So like I said, the data collection, we've got it from three APIs, which is the open weather API. We got it from Eventbrite as well. So we're also taking the events as well. I may or may not include this one, who knows? And then we also have the model training. So we're using gradient boosting for accurate predictions. And we got the edge deployment. So I'm also going to show you the code itself to run it on basically the edge devices like Raspberry Pi and so on and so forth, so that you can basically run your own traffic congestion predictor in real time on a smaller device, on a lower power device. So you don't have to rely on the cloud 24/7, or somebody who has a, like I said, limited IoT infrastructure. This is a perfect project to experiment as well. So the question is, why did I basically picked gradient boosting, right? Like I could have picked random forest, for instance, the ML algorithms. Well, for me, basically, I wanted to handle complex data, because when you're fetching like three APIs at once, it is a lot of intensive. It is very intensive to run those data in real time. So gradient boosting for me basically runs the complex data. It handles pretty well, and it provides the high accuracy with the interpreted results. And so why are we basically running this LLM on this AI based project is that we wanted to run it on the resilience on the cloud infrastructure. So I don't want to take a shot on AWS. I don't know, but so we want to like basically just let the edge device just run it at the same time without having the cloud to do all of the things at once. So you could do it either hybrid, or maybe all the processes at the same time. It just saves you a lot of time, and you can get the data itself, right? So what the data and collection process is, so this is the model that we created itself in JobLib. And we also have the scaler. So we're actually going to have, I'm going to have a Streamlit. So we're going to have a what if scenarios, like what if there's like high precipitation, rain, like in millimeters, right? What if there's like a special event nearby, right? And also the timing itself, and even the traffic itself. So we can also do a simulation of what if I can just show you a little bit. And so let's say, right, maybe like a 1050, like let's see 712, right? There's no data in it. How we can do that? Well, there's two solutions for that. both the things can relies on historical data. One is either filling it with the synthetic data based on the historical data that we have before from the API, or you could basically do the calculate. You could calculate the median of set timing from the past like 30 minutes. So this is the best part about it, is that if, let's say, if the data is missing, you can either do the median, you can calculate the median, or you can handle the synthetic data based on the historical data itself. And yeah, so let me just show you. So why the gradient booster I've showed, which is we've combined the data, and specifically the data set that I've taken is from Abu Dhabi itself, so it makes it perfect for this event as well. And the features, so we've taken let me just go walk through itself. So basically we've taken let me just go down. Wait, okay. Yeah, so basically we've taken the is event. So we've done a lot of if-else prediction. So if, let's say, if we're good to go, then obviously it's green. If it's, maybe you should look into it a little bit, it's yellow. And if orange is like, you know what, maybe that's a little too much. But if it's like red, then that means it's a no-go, basically. So it makes it more, oh yeah. So basically, so if you wanted to just look at the data itself, and also, by the way, I forgot to mention this, I'm basically a streamer as well. So I'm used to a lot of folks asking me questions in real time. So if you got if you want to answer me question in real time, that's fine as well. And
you're allowed to do it yourself. Could you describe the data with which you are working? Because right now it's not obvious what is you put inside of your model.
No, so the data I took in is from 3 APIs. So we took it from, so it's from the weather data and the...
More precisely, it's, I don't know, humidity.
Yeah, so we took the humidity aspect as well. We've mostly taken basically rain and the summer... let me just show you. Yeah, this is the temperature itself. So we've taken based on precipitation as of now, but I want to take the summer as well, like the heat as well. So I want to utilize it for basically folks who cannot handle basically the traffic and the rain, because a lot of in Dubai, because the rain can get very unpredictable. So I'm looking at the precipitation for now. So yeah, hoping that answers your question. Okay.
Show data set.
Let me just, now I want to run the code, but then it has my API key and I'm like, I'm not going to run it over here. But the data set is, okay. Okay, this is the data set. So we took the hours and the days and the temperature and precipitation, the special event, and we also have the road working permit and the vehicle count. So that's the data set we're taking based from the API. I'm hoping I'm answering your question. Okay.
Still no. No, I want to see raw data. Okay, we can do it after the meeting.
Yeah, after the meeting. Yeah, it's fine. So yeah, so that's the data set that we got. And so the best part of this data set, like I said, is that we could also simulate using simulate on agile devices, so Raspberry Pi and so on and so forth. So now I can just show you the demo right here. So we can also simulate the what if scenarios as well. Do you guys have any questions before I can, the demo? Or in the demo? Okay, so let's just go to the app itself. Okay, I am the app. Yeah, I did save the file. So let me, oh yeah. The model itself. Okay. Let's go to the terminal. New terminal. Okay. Stream. Let's run app.py. Let's see. Okay. So yeah, this is the demo that I'm going to show you. It's going to take some time. So if I'm going to do the do, this is exactly why. Just
you have 7 minutes.
Okay. Yeah, that's enough time. So yeah, this is the prediction that was going to look like. So let me just.
For which city? For which city? Abu Dhabi, Dubai?
It's in Dubai. It's in Abu Dhabi for now. And so this is the temperature. So let's just. What's the temperature today? I'm just simulating the what ifs. So let me just give the precipitation. You can also based on time. So you even get the like simulating the graphs itself based on the line chart itself. And then it also, let me just go down, it gives you the recommendation. So if I can just,
for a specific area or the entire Abu Dhabi?
it's in the entire Abu Dhabi city, basically. So let's just increase the, is it current favorable as well? So we can increase the vehicle count. We can also increase the special event nearby. See, now it even gives you the recommendation itself. So it gives you the alternative routes. So consider using side streets or alternative main road. It gives you like, and then if you even increase the road the present itself, you can also showcase as well. And based on that predicting itself, so even the user interface perspective, it basically communicates well on whether you should either try to avoid going to work today or not, depending on the, and even gives you the heavy traffic as well. I just realized I didn't even show the data set. I was showing the app this whole time. So I'm just going to show you the model this whole time. So this is the model that let me just click off this. So yeah, this is the data itself. So this is we're fetching the API so we're taking the humidity and the precipitation from the temperature itself. And if we're going for the location for the Eventbrite, so basically we're just looking at how many people are in attendance based on so if you have like less than, like it returns the amount of events. So if it has like 0, then it would be low, otherwise it would be high. I think it's less than 20 people that I've had so far. And then the location. So this is TomTom's traffic API. I know I could use Google, but if I'm not mistaken, you got to pay for that. And, I like free stuff. So we can fetch it, and then we can look at the free flow speed and the current speed as well. And then once we prepare the data set for Abu Dhabi specifically, we take the API key for the weather, for the event, for the traffic, location, and as well as the number of records. So we're taking like 100 types of records for now. And then we look at the temperature, the special event, vehicle count, and then we train the data set for the gradient booster model. So it all not only handles complex data, but it's very easier to run on a low edge device as well. Like,
why did you choose exactly this model? Did you compare it with the other one?
I tried random forest. Are you talking about the data set or the algorithm itself?
Algorithm. Why did you choose?
Because it can handle complex data much better compared to the random forest, especially when you're taking like 3 API keys as well at the same time. So it handles the complex data in multitude of different ways. That's why I picked that algorithm specifically.
What is the size of input vector do you have for your data?
Maybe the input vector.
How many features?
Yes, how many features
does the model take?
Let me see.
Then, have you looked at the explainability of each feature? Is it actually adding anything to the predictability of the model, or have you looked at any sharp values or any other? Why did you select those specific features, basically?
Okay, so I have my note. I actually have my notes here. So basically, the reason why I picked it is it makes it easier for me to basically scale up the model for the what if scenarios as well. So because I picked let me just check how many features I have. That's why I have notes with me, so that I keep forgetting things. Just decent. Yeah, okay. So, okay, this is the location. So we took the input, so the features itself, it inputs the weather, the traffic, and the event as well. And the predicting condension level was 0. So for 1 is low, but the 5 is high for the condension. And the visualization, it takes the heat maps so it basically takes a time series plot as well, so that for the condensions level. So if there's other algorithms that I want to use, is basically the long-term short-term memory. That's the one that can handle time series data a little bit better than gradient boosting, for instance. But I just want to showcase that you can basically run this model specifically on the data set, specifically on like low edge kind of devices. I could do it now, but I don't have Raspberry Pi with me, so I can just show it to you there. And so the challenges for this data, for basically the main challenge for this is basically the latency. So optimizing for low edge devices to ensure real-time predictions could be a factor as well, especially when you're running on like more sophisticated ML algorithms like long-term short-term memory. So basically our solution is basically take a multi-layer approach and then leveraging public and synthetic data at the same time, like I said. So my solution was basically take based on 30 minutes, and then you can handle just based on relying on historical data, you can basically get the synthetic data, fill in the data from there. And let's just talk about the future work before I end this session, if you guys have any other question. So like I said, yeah.
How did you select hyperparameters for the model? Because I've seen you've used n to 100. Why did you specifically select, for example, 100 of predictors? Estimate, sorry. Yeah. And then the learning rate is 0, 1. So I was wondering, have you tried out any hyperparameter tuning?
No, this doesn't have parameter tuning for now. This is just a simple project that I want to showcase for now. So that's why I haven't picked that specifically. But like I said, this is one of the future work that I want to implement. And possibly I want to implement this on like other IoT-based infrastructure and basically have other multi-city support that isn't just Abu Dhabi. What time do you have now?
Do you have a GitHub repo?
Yeah. Yes, I do have a GitHub.
You can share that later with the folks.
Okay.
Always have it ready as a link. And,
Okay, any questions before I end?
High-level question. Like, I'm very interested why it should run on the edge device. What's the use case that you have in mind? Is it something like related to vehicles running that depend on the model to?
No, because I live, so basically I'm from Somalia, so I live in a country where we have very limited IoT infrastructure. So we basically wanted to rely on utilizing the sensors itself. So that when I want to get the processes at the same time without the reliance on cloud infrastructure, that's why I want to create a use case for my like hometowns. You could say a village, but it's a hometown specifically just for use cases like that. Basically countries who are either having like limited to no IoT infrastructure. So that's,
I mean, like whatever the output, let's say forecasting the traffic for today
Yeah.
or tomorrow, if it's gonna happen once in one place, it's enough. Why it has to be done in multiple edge devices?
No, multiple edge, like a singular device is what I was trying to say. That I'm hoping that answered your question.
I'm just a little bit not convinced why it should run on IoT devices. Like if it's just running in a server somewhere to provide the data, anyone who can consume it, that would be enough.
Yeah, that's fine. But I'm just showcasing like what would work on multi question.
Yeah, perfect. Well, beautiful weekend project indeed with a long range to improvement. I just have a question. Let's assume I am that nerd that I wanna empower Raspberry Pi in my car with the battery, and I wanna use it real time to predict on my phone, visualize on my phone the congestion of the traffic. Why it is giving me like the traffic overall Abu Dhabi, while in, for example, Yes Island, the traffic is less compared to the city here. So I would prefer if it will give me like
multi-city support is what you're trying to say.
Exactly. So Abu Dhabi in general, like
yeah, because
you are fetching the data for the whole Abu Dhabi
area. Yeah.
I can only assume that your data can be biased because a lot of places in Abu Dhabi are not going to be necessarily congested in traffic.
Yeah.
So the prediction you might give me is like, okay, you are good, just go, and then I find a 1 hour stuck.
Yeah.
So this is not really a question, just like
more like an observation.
Yeah, something to think about. But
let's take observations after.
Yeah, okay.
We'll take observations after.
Yeah.
Thanks.
Any more questions before we end?
No, you're done.
Okay, I'm done. Okay, thank you very much, guys.
Thanks.